The sun, our life-giving star, doesn't just shine, sometimes it rages. Solar storms, bursts of intense activity on the sun's surface, can have profound effects on Earth. From dazzling auroras to potential global blackouts, solar storms remind us that space weather isn't just a cosmic phenomenon, it's a force that shapes our daily lives. Welcome to Knowledge Hub. Today we'll explore how solar storms impact Earth and what they mean for our future. Space weather refers to the conditions in space caused by the sun's activity. The sun constantly emits a stream of charged particles called the solar wind, but during solar storms, this wind intensifies dramatically. These storms occur during solar flares, explosions on the sun's surface that release bursts of electromagnetic radiation. Coronal mass ejections, CMEs, massive eruptions of solar material and magnetic fields hurled into space. When these phenomena interact with Earth's magnetic field, the results can range from mesmerizing to catastrophic. When charged particles from a solar storm collide with Earth's atmosphere, they excite oxygen and nitrogen molecules, creating the breathtaking lights we know as auroras. Aurora borealis, northern lights, and aurora australis, southern lights, are natural wonders caused by this cosmic interaction. Solar storms can make these lights visible much farther from the poles, treating places like the United States and Europe to rare displays. While auroras are harmless, the underlying forces driving them can have serious consequences. Solar storms don't just light up the sky, they can wreak havoc on our technology and infrastructure. Power grids. The geomagnetic currents induced by solar storms can overload electrical grids, leading to widespread blackouts. In 1989, a solar storm caused the Quebec blackout, leaving millions without power. Satellites' increased radiation can damage satellites, disrupting communication, GPS, and weather forecasting. Aviation high-energy particles can expose airline passengers and crew to increased radiation, particularly on polar routes. Internet disruptions. Underground cables and infrastructure could be affected by geomagnetic interference, potentially causing global connectivity issues. The most powerful solar storms, known as superstorms, are rare but devastating. The Carrington event of 1859 is the most famous example. Telegraph systems worldwide failed, with some operators receiving electric shocks. Auroras were visible as far south as the Caribbean. If a similar event occurred today, the impacts on our modern, tech-dependent society could be catastrophic, disrupting power, communication, and transportation on a global scale. Fortunately, we're not defenseless against solar storms. Organizations like NASA, NOAA, and the European Space Agency monitor solar activity to provide early warnings. Satellites like SOHO and SDO observe the sun, tracking sunspots, flares, and CMEs. Warnings allow power companies to take preventive measures, such as shutting down parts of the grid to minimize damage. New technologies aim to harden satellites and infrastructure against the effects of space weather. As our reliance on technology grows, so does our vulnerability to space weather. However, this challenge also presents opportunities. Innovation. Developing better shielding for electronics and satellites can safeguard our systems. Space exploration. Understanding space weather is critical for protecting astronauts and missions to the Moon and Mars. Global collaboration. Coordinated efforts between nations can improve our readiness for extreme solar events. Solar storms remind us of our planet's intimate connection with the sun. They are both a threat and a marvel, showcasing the delicate balance that sustains life on Earth. Thank you for joining us on this journey through the cosmos at Knowledge Hub. Don't forget to like, subscribe, and hit the bell icon for more explorations of the universe's mysteries. Until next time, stay curious and keep looking up.